Okay, 5.3, sum and difference properties, day 1. We're going to spend a few days on this. We're going to do kind of some other things besides just sum and difference properties. Besides having your notes out, you should have your trig identity sheet out. It's probably colored or copied on some brightly colored paper, maybe yellow, maybe another color. If you notice on your property sheet, the reciprocal, Pythagorean, and quotient we've already talked about. Those are ones that you probably have memorized by now. And there's a whole slew of identities that we haven't yet done. Okay, so let's talk about those right now. Oops. Okay, so first up, even and odd functions. All right, let's determine what this even means, and then we'll talk about what it is for the 6 trig functions. Okay, an even function means that f of negative x is the same as f of x, meaning that f of negative 5 equals f of 5, f of 16 equals f of negative 16, and so on the graph, this is symmetry across which axis? The y-axis. Okay, so let's think about some trig functions that have symmetry across the y-axis. Let's just think sine or cosine first off. Which of those has symmetry across the y-axis? And remember, x, y, hopefully I don't have to remind you, but this kind of help will visualize it. Cosine. Cosine will have symmetry across the y-axis. And likewise, its reciprocal, secant, also has symmetry across the y-axis. And so this is an identity that will help us on some trig proofs, but also just on some basic problems with numbers. All right, now let's talk about odd functions. Okay, this time when we have put a negative, I'm sorry, let me back up. My apologies, getting ahead of myself. This time, f of negative x is equal to negative f of x. Okay? This is going to create some symmetry, but it's going to be a different kind of symmetry. It's going to be a rotational symmetry. So it's going to be a rotation 180 degrees about the origin. And because it's 180 degrees, we don't really have to worry about clockwise or counterclockwise. So let's think about sine. I haven't done sine yet. Think about if you rotated sine, or basically if you flipped sine, rotated it, and flipped it upside down. If you rotated it 180 degrees, it would be the same exact picture. Likewise, its flip, cosecant, would also have the same thing. All right, I want to be clear here that this is not f of x equaling negative f of x. This is f of negative x equals negative f of x. This is an odd function. And we've done 4 trig functions so far. So I'm going to let you take a few seconds and think about where tangent should be. Is tangent one that you can reflect across the y-axis? Or is tangent one where you're going to have to rotate it? And think about tangent looks like this. All right, tangent's going to fit in with the odds. All right, and so is cotangent for the same reason. Okay, that's on your identity sheet. If you look at your identity sheet, I'll scroll down here a little bit. You can see cosine and secant are the only evens. The other 4 are odds, which seems weird because it seems like there should be 3 evens and 3 odds, like how there's been 3 and 3 on everything else, but it's not like that. This is different. Okay, so you can refer back to this identity sheet if you forget which one's which. This concept, though, of even and odd is something that will carry through into your other math classes, including calculus. Okay, let's talk about cofunctions. The co in cofunction stands for complement. Now we know what complement is. Not a compliment that you give someone, but a complement in math means that it adds to 90 degrees. So what is the complement of 36? Well, we would just do 90 minus 36 and that would give me 54 degrees. Okay, so that's not too bad. You've been doing that for a while. So now let's talk about cofunction in math. So it says the cosine of an angle equals the sine of the angle's complement. For example, sine of 36 degrees equals cosine of 54 degrees. And likewise, sine of 54 degrees would equal cosine of 36 degrees, the same way. And we've actually seen this when we were doing trig in the very beginning with our opposite over hypotenuse and adjacent over hypotenuse. The opposite and the adjacent just kind of switch things. And I told you there'd be a day when we kind of review that concept, and this is that day. That's why it's even called cosine, because it's the complement of sine. So let's do another problem. What would sine of 20 degrees be equal to? I'm not asking for an exact value. I'm asking for another statement here. Okay, it would be equal to cosine of 70 degrees. All right, and there's different reasons why we need to know this. It's always good to be able to substitute in different things, okay, and know how to do that pretty easily. All right, let's practice the cofunction with the others. So what is the cofunction of tangent? We'll just stick a co in front of tangent, and you get cotangent. Okay, what's the cofunction of secant? Put a co in front of cosecant, and you get cosecant. All right, that's why they're named cosine, cotangent, and cosecant. So I know it's kind of confusing because we have reciprocals. We already know those. We're really familiar with those. We have inverse, although I'm not talking about inverse at all here today. But now we also have cofunctions. But the name gives it away. If you're trying to remember, like for instance, on example 1, cosecant of 35 degrees, the cofunction of cosecant is secant. So I would write that first. And then we are going to do 90 minus 35. That's going to be 55 degrees. And these two things are equal. And you can plug this into your calculator, see if you get the same decimal. You will. I'm not even going to take the time to do it. All right. Tangent of 15 degrees. That is going to be equivalent to cotangent of 75 degrees. All right, I'm going to put one more example down here, and that's in radians. Let's say you had sine of pi over 5. Okay, remember that the cofunction of sine is cosine, but how do you find the complement of an angle in radians? Subtracting from 90 won't work, but the equivalent to that in radians would be pi. So let's off to the side do pi minus pi over 5. Okay, that would be 5 pi over 5 minus pi over 5. I'm sorry, not pi. I'm going crazy here. Pi over 2, that's 90 degrees. So my common denominator here, what would that be? 10. So it would be 5 pi over 10 minus 2 pi over 10. That would be 3 pi over 10. That's the complement of pi over 5. Okay? So you're doing the same thing, just in radians. Okay. Okay, now let's do actual sum and difference. Now, before we actually go over the correct formulas, I'm going to show you what a lot of students think the formula is, and we're going to disprove it. So example 3 says, show that cosine of the quantity a plus b is not equal to cosine a plus cosine b. A lot of students just think, oh, distribute the cosine. But remember, you only do distribute when you're multiplying. We are not multiplying cosine times a. We're taking cosine of a. All right, this is very similar to like square root. You're not multiplying the square root symbol by a number. You take square root of a number. And so it doesn't follow the rules of distribution. So just to prove this further, on one side, I'm going to plug in 30 degrees in for A and 90 degrees in for B. And I'm going to solve this down to a number, and then I'll do it to the other side, and we won't get the same number. Now, let's say we did get the same number. That still wouldn't be a proof for it, because all you ever have to do is come up with one counterexample to disprove something. All right, and the fact that I've already told you that this is false all you got to do is come up with one counterexample, and I've given you the numbers to help you do that. Okay, so this would be cosine of 120 degrees. Now, you should be really good at these by now. All right. What's the reference angle? Okay, reference angle is 60 degrees. This is in quadrant 2. All right. So cosine of 60 is 1/2, like sine of 30, cofunctions. And then in quadrant 2, all students take calculus, we get a negative 1/2. Okay, on the other side, let's do the same thing. This time it's cosine of 30 degrees plus cosine of 90 degrees. Now cosine of 30 degrees is going to be square root of 3 over 2. It's in quadrant 1, so no big deal here. And cosine of 90, we're going to have to use the OIO chart. Okay, so I'm not going to write the whole thing down, but we can start OIO, IOU. So right here, I see that cosine of 90 is 0. Okay, even if it had been 1, still wouldn't get this over here. So square root of 3 over 2, these two things are not equal. So just one counterexample, not true. This right here is not an identity. It does not work. If you can find that it worked for one example, that's still not enough to prove that it is true. Okay, let's, I'll keep hitting that thing too many. Okay, it's saying simplifies using the sum and difference property. So before we really use these in proofs, we're just going to use them to simplify. So there you go. This is the trig identity sheet. Here are your cofunction properties, and there's pi over 2 instead of 90. And those are all the same things that we talked about. So here we go. Here's the composite argument for sum and difference. Okay, and so notice that you have a sum and a difference for sine, cosine, and tangent, and for the reciprocal identities of cosecant, secant, and cotangent, you can just flip over these identities, and we'll have at least one example of that. Okay, so if I look at this, it looks like I have, I'm going to go ahead and write it out using A and B. It looks like I have cosine of A times cosine of B, and in this case, A here is equal to 20 degrees, and B is equal to 34. So for the rest of this, this would be sine of A times sine of B. Now you got to be really careful here, because as we go back and I'm looking for this identity, notice that they look very similar. All four of these look very similar. So which one has cosine A, cosine B? I already forgot what it was. Plus sine A, sine B. Every plus and minus counts. Okay, so cosine A, cosine B plus sine A, sine B is the same as cosine of A minus B. All right. I wouldn't advise that you memorize these. It's just not, I'm not going to make it mandatory, and they're too easy to get mixed up. So refer back to the chart on these every single time. All right, this is not a proof, so this is why I'm not worrying too much about notation, but I'm clearly showing my work anyway. All right, so then this is going to be cosine of A is 20, and B is 34. Hold on, I'm going to look at. Okay, so then 20 minus 34, that would be negative 14. And it may seem like this is all I can do. However, because cosine negative 14, if I go back up here and look at evens and odds, okay, cosine of negative 14 is the same as cosine 14. So you got to ask yourself, which is simpler? Cosine of negative 14 or cosine of 14? Cosine of 14 is simpler, so that should be your final answer there, cosine of 14 degrees. Okay, so I used sum and difference, and I used cofunction in that because it was an even. All right, if this had been sine of negative 14, then I could do negative sine of 14. All right, at that point, it's arguable about which one would be more simplified. Definitely here, though, this is the most simplified. Okay? And if you were doing a problem in calculus, cosine of 14 degrees, much easier to work with than that whole thing, okay? All right, now we have a proof with the sum and difference properties. Okay, so want to start with the more complicated side. So I'm going to go ahead and write it down. Cosine of x minus pi. Now in this case, I'm going to treat x like a and pi like b. So when I apply the property, in fact, when I go over here, we just used this property, but you probably don't remember it, so I'm going to go back and look it up. I'm going to go ahead and see if I can capture this and put it on my page just so we can see it. Okay, there it is right there. You have your page next to you, and now it's even on here to see. So this right here is going to be equal to cosine of a, which in this case is cosine of x, times cosine of b, which is pi, plus sine of x times sine of pi. Now remember that pi is 180 degrees, so we need to use the OIO chart to do some simple substitution. So I'm going to go back a page here where I had the OIO chart, and I'm going to finish it out a little bit. So sine of 180 is 0 and cosine of 180 is -1. Okay, so cosine x times cosine of pi, or 180, that's -1. All right, then we have sine x times sine of pi, that was 0. So essentially what that does is gets rid of that whole term. And I am left with negative cosine of x. There we go. Okay, so that's just one place where you could use the sum and difference property to prove. All right, example 6 is another one. I don't have a cosecant difference property, but I have a sine. So let's go and, well, let's first just go ahead and write this down. I know this is the side I'm going to start with. And again, this is going to be like my A, that's going to be like my B. Okay, so let me go and capture that sine A minus B. Okay. So I really do need to show this step, and we can't bypass this, even though you might be tempted to. We do need to show that step before we start the substitution. All right, 1 over. And don't leave out the 1 over thinking, oh, I'll add it in later, because even if you remember that, that's just not a good proof. Okay, so sine of A minus B, in this case A being theta, B being 90 degrees, is going to be equal to sine of A, or in this case sine of theta, cosine of B, cosine of 90, minus, extend this line, cosine of A, cosine theta, times sine of B, or sine of 90 degrees. Okay, so again, let's go back and refer to our OIO chart. That OIO chart's just going to haunt you forever. So sine of 90 is 1, cosine of 90 is 0, so let's take this back. And some of those you may have memorized as well. Okay, so 1 over sine of theta, cosine of 90, remember, was 0. Minus cosine of theta, sine of 90 was 1. So again, like the last problem, that becomes 0, and I am left with 1 over negative cosine theta, which is equal to negative secant theta using the reciprocal property. And there we go, there's our proof. Now there's actually an alternate proof that's shorter than this that doesn't use sum and difference properties. What it uses instead is the cofunction property, since this is a 90 degree here, but the actual property is 90 minus theta. So what you have to do instead is you have to factor out a negative and use even and odd properties as well. If you're up to the challenge, see if you can do the proof that way. And then if you want me to check it tomorrow, I can. This is fine, though. This is how most students would do this problem. Bring your questions to class.